Basic organic compounds exhibit properties similar to inorganic bases, such as the ability to accept protons and donate pairs of electrons. They have a higher affinity for protons compared to water, resulting in a basic or alkaline nature. The basicity of organic compounds is dependent on various factors, including the nature of the substituent, steric hindrance, and resonance effects. Basic organic compounds, also known as amines, are organic molecules that contain the amino group NH2 as their functional group. Amines are derived from ammonia by replacing one or more hydrogen atoms with organic substituents. They can be classified into three main categories based on the number of substituents attached to the nitrogen atom: primary, secondary, and tertiary amines. Primary amines have one alkyl group or aryl group, R, attached to the nitrogen atom. Secondary amines have 2, and tertiary amines have 3. Aromatic amines, where the nitrogen atom is attached to an aromatic ring, are also considered basic organic compounds. The Hinsberg test is a widely used method in organic chemistry for classifying amines into primary, secondary, or tertiary amines towards a sulfonamide reagent, and is often employed as a preliminary test before further characterization or synthesis of the amine. Here is an overview of the Hinsberg test procedure. You add a given volume of the Hinsberg reagent, which is benzene sulfonyl chloride, to the test tube containing a measured weight of the unknown. Mix the content of the test tube gently and observe the reaction. If the amine is a primary amine, it will react with the Hinsberg reagent to form a sulfonamide and precipitate out as a white or off-white precipitate. If the amine is a secondary amine, it will also react with the Hinsberg reagent to form a sulfonamide. If the amine is a tertiary amine, it does not react with the Hinsberg reagent and remains unchanged, showing no precipitation or solubilization because it does not contain any replaceable hydrogen.
In a nutshell, I need you guys to understand what this practical is all about. We provided with two samples, sample D and E, alright? And these samples, you don't know which of them is the primary, it's the secondary, or even the tertiary amine. And reagents such as the HCl, sodium hydroxide, and parasulfonic chloride will be at your disposal. So how would you know if it's a primary amine? If it's a primary amine, the addition of that 10% sodium hydroxide and parasulfonic chloride will form a precipitate. You don't know the color yet, but that precipitate is a sulfonamide. And upon warming the same solution, it gives you a clear solution. Once a clear solution is observed, that means the precipitate dissolves. That tells you that that sample, which is either D or E, we don't know, is a primary amine. So if the sample is a secondary amine, the addition of same 10% sodium hydroxide and parasulfonic chloride will also give you a precipitate, a sulfonamide. But that sulfonamide will not dissolve on warming. So that means it remains insoluble. So once you get to observe that, you know that the sample is a secondary amine. But if the sample is a tertiary amine, the addition of the same 10% sodium hydroxide and parasulfonic chloride would not show you any visible reaction, no changes whatsoever. So even if you warm, there will be no changes, nothing happens. That tells you that sample is a tertiary amine. And why is that? Because there's no replaceable hydrogens in the tertiary amine. So as a background knowledge, I need you to fully understand that amines are basic in nature. So they are all expected to react with hydrogen chloride to form salt and water. That's on treatment with hydrogen chloride. And how would you even know? Because the test tube will feel hot due to the exothermic nature of neutralization reactions. So try to report correctly and good luck.